Calling all educators, students, and space enthusiasts. The 2025 Small Sat Education Conference is where the future of space begins. Join us at the Kennedy Space Center for hands-on workshops, expert speakers, and industry networking, all focused on bringing small sat innovation into the classroom. Explore CubeSats, high-altitude balloon missions, and hands-on STEM workshops designed to launch the next generation of space explorers. Don't miss this chance to connect, learn, and innovate. Visit smallsateducation.org to register today. You can find a link in the show notes. Let's go to Space Blue Sky Learning, episode 154, Engineering and Entrepreneurship. Today, Kevin and I meet with Raz Idan, who's been an educator for almost 20 years, working as a guide in multiple science museums and even at an astronomical observatory. He's a self-proclaimed space nerd with degrees in physics, materials engineering, and a master's in space systems engineering on the horizon. Raz brings his passion for education and space together in his professional life, currently teaching Engineering and Entrepreneurship, or E-squared, at the Leffell School, which is a K-12 private school in Westchester County, New York. He launched the space engineering elective this past year, and his students developed a payload box that will be launched on a high-altitude balloon, aiming to pass 100,000 feet. This coming school year holds even more exciting space-related activities in store, and in his spare time, Raz has picked up hobbies such as observational astronomy, astrophotography, and ham radio, which he often incorporates into his classroom. This is going to be a fantastic episode. We hope you enjoy it. Welcome, Raz Idan. Thank you so much for spending some time with us today. Remind our listeners a little bit about who you are and how you came to get involved in space.
Yeah, thank you so much for having me. So my name is Raz. I am a teacher at the Leffell School in New York. I've been interested in space since I remember myself. It's not like a cliche. I had a book called The Universe. Um, when I was 4, I could not read yet, but I looked at pictures. So I really loved space since I was a kid. Um, I got into astronomy. So I got into observational astronomy, and I did some astronomy just for fun and also for work. And I got to work at some astronomical observations. And then when I grew up a little bit and I went to college, I studied engineering and physics. But space was still a huge interest of mine. I got to volunteer at Space IL, which is a nonprofit organization in Israel that developed and built the first Israeli lunar lander, Bereshit 1. Um, it was a part of the Google Lunar X Prize competition. The lander did crash, but even getting to the moon was a huge success. So I was very happy to be involved in that. And finally, I moved here to America. I started teaching engineering. And very recently, I started teaching space engineering, where we're kind of building the curriculum with the students, figuring out what they would like to know about space. And we're doing some really cool, stuff.
You said that was a high school, right? Is that correct?
It is a high school. I teach, well, the Leffell School is a K through 12 private Jewish school in Westchester County, New York. We have a vision where space is introduced through all the grades. So while I'm teaching directly, I'm teaching 9th through 12th. I am in charge also of introducing space at the lower school and the middle school. So maybe not a rigorous curriculum, but some
Yeah,
activities.
get them excited about it.
Yeah, for sure, for sure.
So when you talk about integration, all right, and we've worked at a few schools where it was integrated a little bit, at least with Kevin's work, or I work with students in debate or public speaking, where it was integrated across all grades. That can sometimes be challenging, right? So how does your school, if their focus is on space, is it something that you are challenged with kind of creating a scope and sequence for the way you're going to introduce the content? And then ultimately as well, is it something where you're doing project-based learning where it's something that can follow the students over time?
Yeah, that's a great question. So I am fortunate enough to work in a private school. So we don't have to match any standards. The school obviously does meet all the state required standards, but in terms of curriculum, when it's an elective like space, I am free to do whatever I want. Um, in the lower school, we're trying to introduce it, in bits, in a way that still matches the way that the lower school teachers teach. I'm not there to work against them. I'm there to work with them and get them excited. In the high school, my course is definitely project-based. This past year, we started talking about space and about space systems. Um, and we said, okay, let's go to space. We can't really get to space right now, but let's get as close as we can. And together we developed a mission of a high altitude balloon. And the students were involved in all the aspects of the mission planning, the mission design. They built the payload box. They designed a custom PCB that includes all the sensors. One thing that I actually want to do with them was say, okay, we're going up there, to the edge of space. We're trying to reach 100,000 feet. What should we do when we're up there? And they were like not really sure. So together we came up with this idea. Let's go to the science department in our school, which is a separate department, and ask them to work with their students um, on this mission. So it was a great collaboration. So what the science department did, the science department teacher um, had a lesson about the layers of the atmosphere. And then they asked their students, which are not my students, there's no overlap, if you could go to the edge of space, to the upper stratosphere, what would you want to measure? So they had this activity in that class. They came back to me with a few questions. For example, what's the ozone concentration up there? Or how does the temperature change as you go up? And based on those questions, we integrated sensors into our payload. Uh, so when we launch early next school year, we'll be able to answer those questions that were raised in the science class.
Very cool.
Yeah.
Did they raise a question about particles or like the elemental composition at the very top and density or anything like that?
Yeah, so they had a lot of good questions.
Very good.
Explained, my students came to their class and explained the limitations, the weight limitations, the size limitations. So we settled on three big questions, which was the temperature, as you go up, how the temperature changes, the ozone, and particulate matter. So basically air quality. Uh,
Right.
they expected to see how there's fewer particles as you go up. So they raised the question, they explained what they expect to see, and we're hoping that our experiment will match the
Right.
expected theory.
Uh, don't you? I see this. Perhaps you could expand on this. Balloons are really cool. High altitude balloons are good because sort of like the Venn diagram of excitement and optimization and pragmatic, right? They're doable in the near term. They're not too expensive, but man, you have size, mass, power constraints just like a spacecraft. I think they're the perfect training tool for satellites. What are your thoughts?
I agree. I couldn't agree more. The way the students kind of divided themselves into teams. One student was in charge of the mass budget. right? So every time another student would come, it's like, oh, let's add this.
Yeah.
No, my mass engineer would say, well, let's look at the sheet. No, you can't. That's too much. Another student was in charge of the power requirements. How many batteries do we need? What do we expect the power draw to be from the camera, which is our probably the biggest power load. The excitement here is that they're really building this mission, right? It's on them. If we fail, we fail together. If we succeed, we succeed together. They had to call the FAA to make sure that they're meeting the requirements. There are some requirements that if we exceed, then it gets more complicated. And as long as we're under a certain amount of mass or a certain amount of volume, then we're clear to launch. So they were really involved in every step of the process, and we're not done yet. Right now, they're in summer break, in camp or in their internships. But I'm excited to regroup in September, and we'll launch very early. Our goal is 100,000 feet. Yeah, it's very exciting. I encourage every teacher who's thinking about it to start with a high altitude balloon mission. It is exciting. It is doable. It's like you said, not very expensive, definitely compared to a real space mission. Um, and it hits all the requirements of we're doing engineering and we're doing project based, and we're having fun and we're learning.
Science,
Yeah, all
math.
of it. Well, two comments and then kind of a question. So first of all, I think it's very um, it's more meaningful for students, right, when they are teaching each other and then learning at the same time as each other. So the idea that you're collaborating with these other classrooms, not only is it reinforcing or teaching new knowledge, right, but it also then is encouraging some of those science students who aren't yet in your elective to maybe take that at some point because they think, wow, I can actually see the applications of math here, right? But also, I think it's important to note that high altitude balloons, while you're right, they're doable. Like a teacher could do one in a semester, in a quarter, maybe, or a year. But you have the luxury also being in a private school where you could continue to kind of take that even long term, because you even, let's say this is a year-long process where they have to learn about it and then they're breaking it down. In other schools, like we both worked in private schools, but in public schools, you're right, you have these kind of parameters that makes it harder, whereas a high altitude balloon, maybe you can launch it within a window that a teacher doesn't just have to say goodbye to their students at the end of the next year and they get a whole new set in. There is that luxury of having the same kids take your class from year to year. It helps you with your program, but also builds their program, or their resumes rather. But I'm interested in figuring out, I understand where you get the engineering part in. Tell me how the entrepreneurship part of your class comes into play.
Yeah, that's a great question. So when I started working in the school, I started as a teacher in the Engineering and Entrepreneurship program. Um, this was the school was the first school to have this maker space that's focused on engineering, but also entrepreneurship. It's now much more common, but this was the first Jewish school to do that. Um, and we're kind of a shoot. We're shooting off of this main branch of engineering and entrepreneurship. Our engineering and entrepreneurship program, I'm gonna zoom out a little bit, teaches students how to build something, but it's not just building something for the sake of building. It's building something to help other humans. Um, so there is I'm not religious, but there is a concept in Judaism that's called tikkun olam. In Hebrew, it means tikkun olam. It means repair the world. Basically, do something good for the world. So our school is very, very attuned to that. In the engineering program, the way it works is that once the students learn the electronics and the coding and the fabrication, how to build something, then they're tasked with, okay, solve a problem. So go out there into the world and observe people, talk to people, figure out what a group of people, or maybe even one person, what they need. So it's not that you solve what you think needs to be solved. It's you solve what you know needs to be solved. You've done the research, you've talked to people. Um, so we do this by working through the design thinking philosophy, a lot of empathy, a lot of understanding what the human needs. And once they have that question, right, how do I address this issue? Then they start building a prototype. Um, and we've had a lot in the last this program has been running for 13 years. We've had students being very successful. Some have continued to create to file their own patents for their prototypes. But I think what I'm more impressed with when I see them really uh, 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 um, what's the word? They're impressed by themselves, right? That's what really gives me that like, wow, that's the experience. Sure, I can be impressed by them. It's when they get to be impressed by themselves is that we know that we checked that box.
Well, it's moved them to that next level of not just like dabbling in something, but to taking ownership in it. And then from there, I mean, that's really creating probably a lifelong interest that somebody that might choose that as a career field.
Right. And if you really think about it, science is to better understand the universe, but engineering is applying that knowledge to create devices or tools to improve the human condition and to help us better study the universe. So, uh, this is really, I did not actually know that you had this applied engineering focus for the good of the community. And while you guys were talking, I listed like seven or eight, like clean drinking water, right? Free electricity, free internet, free education, protect the biome, remove microplastics. There's some serious problems, for instance, that I challenge my kids. I said, my generation has messed up the earth. I need you guys to fix it, right? Sort of like passing the torch. Like we're admitting we did a lot well, but we did some things really badly. So this is a wonderful challenge. Let me ask you this. So you're a Johns Hopkins graduate, correct?
I'm finishing this semester, yes.
Congratulations, because that's not your average community college that you're cakewalking through there. So what was the most exciting as far as a student, right? In your master's, what is the most exciting thing that you've done there with Johns Hopkins University?
Um, so yeah, this is the Engineering for Professionals program. So every student in that program is a full-time, employee somewhere. Uh, and I think the really exciting thing here is that the teachers, the professors, are all uh, professionals who are currently working on space missions. So I have been, instructed by engineers who are working on the Dragonfly mission that's going to go to Titan,
Fantastic.
right? I've been,
Could you share a little bit about Dragonfly for our listeners that may not know?
so I don't know a lot. It is run by APL, the Applied Physics Laboratory. It is going to be a NASA mission that's going to go to Titan, a moon of Saturn. The really cool thing about that mission is that it's kind of a helicopter. So it has rotors and it will fly through the atmosphere of Titan. And it's a very cool mission. Really unique. I think there was a lot of lessons learned from the Ingenuity helicopter on Mars to facilitate, another powered flight on another um, solar system body. So that's a really cool mission. I think it's going to launch in a few more years.
Right. And for our listeners, Saturn's distance means that that's like a fully autonomous flying vehicle, right? There's going to be no joystick guy in Houston or JPL or wherever flying this thing. This thing's going to do its own thing.
Correct, correct. The light distance to Saturn is probably upwards of 30 minutes, maybe even an hour. So you can't just stick right and expect it to fly right. It's going to take an hour for that signal to get there. So
Right,
it is fully autonomous. It is powered by basically a small nuclear reactor, right? There's not enough solar power to be generated there. So they're going to use a small nuclear reactor. Very exciting mission. Very exciting to hear about the engineers,
right.
sorry, from the engineers talking to us about their challenges. Um, and APL had a lot. APL is the Applied Physics Laboratory
Right.
at Johns Hopkins. APL had a lot to do with space missions.
Right. APL was there at the very beginning of America's space program, right? They are very well respected. Do you find that you get a little more go fever from having been around people like that?
For sure. I mean, it's so exciting when they're saying, let's talk about this mission. And they're showing a graph or an image, and like, oh, I actually built this engine. Or, it's super exciting, and the amount of information you just want to take in from those people uh, is uh, is amazing.
So, how many years have you taught at your school, and do you have enough time there that some of your kids maybe have gone on to college, maybe gotten through college? Where are you at in the life cycle of, I'm going to help imprint some of these young people, and then they're going to be that aerospace STEM workforce?
Yeah, so I am, I think it's my 8th year, starting my eighth or starting my ninth. It's all a blur by now. Um, but many of our students went on to engineering. A few went on to aerospace engineering. A few are working in aerospace. One of our students is working at Sierra Space on the Dream Chaser. Um, it is I'm always excited to hear about where my students are going, even if it's not engineering. But we do have a collection of mugs. So if a student, when they graduate, they go to either computer science or engineering, they bring in a mug from that school. So we have a big collection of mugs from um,
That's really cool.
Yeah, I like that
Are you
idea.
able to
That's good.
leverage any of your graduates to come back and be role models for your current students? Because that seems like that would be a really great tie-in.
Yeah, we've had a few come in to talk to our students. Usually it's harder, they find their job, they have their own life. But um, a lot of it's interesting. I see that as long as they're in college, they come back over their breaks.
Yes.
Once they graduate, I guess they figure out, well, I have other stuff to do, so we see them less. Um, but we definitely see them while they're still in college. Over their breaks, they come in, maybe they even hang out a week, help our students with the electronics, with the Arduino. Um, One thing that we work on, it goes back to the question of like how does internship come into that? So we work not only on the technical skills of coding and building, but also on what we call power skills. Sometimes it's called soft skills. We don't like that name. We like power skills such as public speaking and collaboration. So our students have to present. So whenever we have a guest, a visitor, maybe it's a graduate, maybe it's a parent, maybe it's some a donor, we would just grab a student and say, hey, Michael, give your 2-minute pitch. And they have one ready. They have a 2-minute pitch ready about their product. What is the need? What is the solution? How are they working about it? Working around it? Um, and that's a skill that we believe that if you want to learn coding, you can learn coding. You don't need school to do that. In the age of information, you can do that very easily. Um, but collaboration and public speaking, those skills that you have to immerse yourself in if you wanna do right.
Oh, he's looking at me because he's like, oh, that. So I
Well,
finally get, yes, this is the one role that I have, right?
well,
But that
you're
we found that it works well together, right? So Kevin works with the students for the content, whereas I, as an English and a debate teacher, work with our students if they're writing papers, getting it to be published at the university level or at conferences to present, right? But it's something that no matter what career field, being able to talk about what you're learning and to different audiences too, right, is super important, whether they're talking to the younger kids or to an investor, as you
we
said.
we have echoed what you just said for almost a decade, right? I honestly think, and by the way, my sweet spot is I think I do better with middle school kids than high school kids. High school kids in small groups, but middle school classes, right? I think what you call the power skills, what we call the soft skills, I actually think that's more important, like you said, than the technical content because their employer is going to teach them that job, right? But they can't make them good employees, right? They can't make them collaborators and good communicators. And how do you speak up but not be a bully, right? How do you either not get run over or run over anyone else? That's incredibly, I think, valuable
Or even
today.
convincing people on your team. So
Yeah,
you have these
persuasive
teams
speaking.
where somebody has an idea and there are another ideas, like how do we work together to make sure that all those, parts are heard. So excellent that you're considering that. If we have a moment, I'd like to, if you're allowed, to share what some of these projects are that your students have been working on to solve.
Yeah, so I have a few examples in mind. Kevin, you talked about microplastics, right? So just this year, we had a team, and this comes from them. I'm so happy to say when it comes from them, they built a robot to clean beaches. Basically a Roomba for a beach. They used an AI capable camera. It's called a Husky lens. It's actually very inexpensive, and you can do some simple AI stuff. So they taught the camera to detect what a can looks like or a bottle, and how to track it, pick it up, throw it in a bin.
I'm laughing because Dylan Keesley, one of my kids actually went to the state science fair with that almost identical project of a robot using machine learning, right, to get better and better at identifying trash. That's
Yeah.
fantastic. I see microplastics as a truly that's the issue that resonates with us. That's our
Well,
fourth satellite mission.
when your students do something like this, and certainly feel free to share about others, but I'm curious as to, again, it's longer than a school year. This is something that a student can really sink their teeth into over a period of time and really have an impressive
Like a
portfolio by the
yeah,
time they
portfolio.
graduate. So do they go on to patent these items or?
Mhm. So a few do. We do. Uh, we've had a member of a member of our community as a patent lawyer. So when he's available, he would come and talk to the students about what it means to patent, um, to file a patent. So some students file a patent. Some are like, okay, that was cool. Next year, I'm going to do a different project. Uh,
Mm.
we we it kind of goes back to our belief that what you build is going to be cool, um, but the main experience is that collaboration and how you present it. And then when you grow up, if you want, now you have the skills to pursue that.
Right.
Um, so we don't push students to do that. We do participate in engineering competitions, and we do pretty well. Um, but we really want the students to decide if this is their passion.
Right,
Right.
whether it's more philanthropic and helping the communities with this great idea, or if it
Right.
becomes a business that they might want to go into and
Right.
and start.
Your deliverable is
Students,
good citizens, right? And capable. Your deliverable is the workforce, right? You're dealing in people capital. We call it human capital development. That's the game you're in. All
we
those
say we
other things.
produce menches.
What's that?
We say we produce menches. A mensch,
Menches. Good
good
guys.
person. Yeah, good guy.
Fantastic. Yes. No, I totally. sometimes we get wrapped up in, or our kids are publishing papers and, like you said, the patents and things. But what you're really doing is setting them up to be serial entrepreneurs, right? In fact, some would say that you need to fail a few times before you really get it right with entrepreneurship. And why not do it when they're 14 or 16, when the repercussions are a lot less,
For sure.
financially expensive or
Well,
things
and
like
it
that?
takes the kind of, those things are scary. Like even for adults, the idea of like, oh, I have this great idea to start a business, but I don't want to like file an incorporate, incorporation or whatever. And I don't know what that means. And how would I go? It takes away at a time when they're younger and they're less fearful, right? Because I think that as we become adults, it's easier to sometimes become afraid of change. When you're younger, it's like, what if I got to lose? They don't even know that they're not supposed to be doing it, right? We say that a lot about satellites. Like middle school kids aren't supposed to be launching satellites, so they don't know that they can't do it. And I think that by you exposing them to it as an industry, right? Because it really is through an industry lens. You're saying that there are many facets within, let's look at aerospace this way. You can be a business owner, you can create something, you can work for other companies, you can patent these. They're learning really about life in your class well beyond than just
For sure.
content. Yeah.
I have one more example of a product that is probably have a very minimal effect in your everyday life. A team of students created a honey warmer, right? They didn't like the fact that honey crystallizes on the shelf, so they built a honey warmer to dispense honey. Now, their tagline was sometimes it's the small things that count. Um, I love this project so much because one of the students, when she came into this program, was a terrified, quiet, shy person. By the end of that year, she, with her team, uh, presented their product so well. Even though it's a silly, cute little product, they presented so well, they won an award for best brand.
Mm.
So whenever they would present, they would um, color code their clothes. They had a great brand all about honey.
So she
So
learned marketing.
she learned marketing. She's not going to be an engineer. It's not her interest.
Right.
It's okay. We're not necessarily producing engineers or entrepreneurships. We want to produce people who are confident in themselves and can present and discuss and talk to others. So that is why this silly, cute little product is so like stuck in my head because of the process that this shy student went through.
Well, yeah, that was a
Yeah, you,
development for
you,
her.
you gave, she found ownership, right? It's when the kids get
Yeah.
ownership that they really can grow. It's sort of like we're in two places trying to do the same thing. I'm a really big fan of you, Roz. You already know that, but this is only further solidifies, um, you're doing a lot of really good stuff.
Well, before we get to our final question, I'm interested to find out whether or not you have like we have here philanthropy tanks where kids can present to get funding and things. Do you have things like a little mini Shark Tank up by you where your students can enter these kinds of competitions?
That's actually a great idea. So the way the students in class are a big component of their grade is a Shark Tank-like presentation. So they present to their classmates. There's a Q&A session, and how they handle that Q&A session, how they present, that's part of their grade. Um, like I said, we do go to engineering competitions. Um, we don't really try to fundraise for those products. And even more so, when we bring in MVCs, which are mock venture capitalists, which are members of the community with the business experience, but we don't ask them for money. We ask them for advice. Um, so we believe that once those students, if they're passionate, we're going to support them in what they want to do. But we want to give them a taste of what it's like to build a small company, design a product, and then move on to the next thing.
Right, right. Keep learning, right? Well, this has been fascinating, and I really want to thank you for spending some time for our listeners as your parting words. Let's say that there are some teachers out there who are inspired by what you're saying today and they're interested in maybe bringing this kind of concept to their classrooms, what would you say?
Yeah, so I think I have advice for teachers and advice for students. Advice for teachers is I know sometimes in administration is not so happy with change. Um, Push through, find someone in the administration that you can talk to, that you can convince, and work with the administration to create the project and the program that you want to, right? You can do it. You just got to find someone that can help you from the administration. Um, Very similar piece of advice for students. If you're interested in something, find that expert, that person that you can talk to. Send them an email. Go on a Facebook group and ask people. But don't be shy. Basically, don't think, oh, that's too big. If middle schoolers can send a satellite to space, then any student can do whatever they want. They probably need some help and some advice, and there's people all over the place who are willing to give that advice.
Perfect.
Don't
Great.
be
Really
shy.
appreciate
Yeah,
this
great
time
advice.
today. So I'm sure that Kevin will be talking with you more as he said, you all have some similarities in common. But thank you so much for spending your time today.
Thank you so much.